Welcome back. So we're going to talk about force, moment arms, and torque. And torque is really what strength is when we're talking about the human body. I joke that torque is life and moment arm is just runs everything about torque. All right, so let's talk about force. Force is a push or pull on an object. When a force acts on an object some distance from an axis of rotation, it creates what we call a torque or a rotational force. And this distance from the axis of rotation is called the moment arm. So in this example, we have our axis, our pink axis. We apply a force and it causes at a certain distance, the moment arm, and that causes a rotation of this dark limb, if we will. So torque is basically how we function in the human body. We don't really generate force. We generate force at joints, which is actually torque. So specifically the moment arm, it is the perpendicular distance between the line of action of a force and an axis of rotation. So whenever you're thinking about the torque for some exercise or movement or at a joint, you always search for the axis of rotation, the elbow joint. And then we have our internal force, and the perpendicular distance is this dr, and that is our creates our internal torque. So the internal force times d creates our internal torque or muscle torque. And then we're trying to look at the line of action of our external force. It is at a longer moment arm. So the perpendicular distance is d1. It's much longer. And so that external torque is the external force times d1. And the internal force is creating a flexor torque. The external force is creating an elbow extensor torque. So torque, again, is force times moment arm. If you increase the force, you will increase the torque. All right, that's pretty standard. And generate more muscle force, you will generate more joint torque. However, also increasing the moment arm will increase the torque. So here we see there's torque. You have the first moment arm applied perpendicularly to the force, or you can lengthen that moment arm with the same force and you will have a much higher torque. And kind of the opposite of that is how do we make things less effortful? So you can provide the same torque with less effort or less force by increasing the moment arm. So here, if we want the torques to be the same, we have the moment arm here on the left times a larger force. If we increase that moment arm, we can decrease the force to create the same torque. And that's why doorknobs are on the opposite side of door hinges. And think about it when you're going through a sliding or like a rotating door. Like if you go in and push close to the axis, you have to apply a much larger force than if you're further away of that axis of that rotating door. All right, so let's focus on external torque. And we're gonna just get some terminology down. Here we're gonna look at the elbow joint. So we have the humerus, we have the ulna, and we have our brachialis actually here, the elbow flexor muscle. So the external force is always acting down due to gravity, and the EMA, which is the external moment arm, is perpendicular to that force. The thing to note is your external force in all of these three conditions, right? So this is when your elbow is flexed, the center is when your elbow is extended to 90 degrees, and the right image is when your elbow is extended more. The external force is the same in all of these three positions because the dumbbell has not changed weight. However, the EMA, or your external moment arm, has changed length. So the external torque is actually greatest in the center image not because the external force has changed, but because the external moment arm has increased. Here's another example without a weight. So the weight here is just the weight of your arm, and they say it's 35 newtons. So we have three different cases. So full abduction at 90 degrees, C, less abduction at B, and then your arm just naturally down at the side, fully adducted at the side of your body. So the weight of the arm is the same, but through these A, B, and C, your external moment arm increases, and therefore the torque increases. And you can see it for image A, when your arm is at the side of your body, there's no torque because there's no external moment arm. So the weight of your body is the same, but the torque it produces at the glenohumeral joint changes depending on the position of uh, the arm with respect to the glenohumeral joint. So as you increase abduction, you will increase torque without changing the weight of your arm. Another example is different back squats. So here we have a typical back squat, and so this is what you're lifting, and it goes in the direction of gravity. And then we can say, look at the external knee moment arm and the external hip moment arm, right? So there's a larger external torque at the hip for this back squat than at the knee. If we do a low bar back squat, we switch that and we increase the hip moment arm. So we increase the torque or the load at the hip and decrease the knee moment arm. So going to a low bar back squat would kind of shift this exercise to focus more on the hip and the hip extensor muscles than the knee extensor muscles, all by not changing the load or the weight you're lifting, but by changing the external moment arms. So let's look at the internal torque side, right? So an external torque is always countered by an internal torque. So this is the same elbow joint. And here we have the internal or the muscle force, and it acts at a very small internal moment arm. And throughout the extension of the elbow joint, so left is flexed, center is extended at 90 degrees, and the right image is extended more. The internal moment arm, even though it's much smaller than the external moment arm, it does change and it does affect the internal torque production and is also very important. And again, you cannot change your internal moment arm because that is based on where your muscle is inserted. And note, the internal moment arm is not the distance from the joint center to the insertion point. It's the distance from the joint center to the line of action of the internal or muscle force. We can see here a little closer. Here's your muscle force, and it is not this distance to the insertion point, but it's the perpendicular distance from the center of rotation or the elbow joint to the line of action of the force. And the images on the right just show how it changes. And even you do generate more internal torque at 90 degrees because that internal moment arm is slightly higher. Here's a view of our knee joint. So on the right, you can see it's a sagittal view, and this is our femur, our tibia. You can see the center of rotation, and this pink is the line of action of the quadricep muscle, which you can see after the tip of that pink arrow, and it goes anterior to the patella. And so you can see that patella increases this internal moment arm quite a bit, which increases the torque production of our quadricep muscle. On the left, it kind of illustrates the difference in internal moment arm with and without the patella. So on the left, you see no patella, which decreases this moment arm, which will decrease your knee extensor torque. And with the patella, you increase that internal moment arm, which greatly increases the torque production of our quadricep muscles. And when people have no patella due to a fracture in what they call a patelectomy, they are much weakened in knee extensor strength to the point that they cannot walk.